Sounds good.
All right, so I'm gonna kick things off here. Welcome everybody to Minneapolis LabVIEW User Group Q1. It's amazing that it's already Q1 2021. Feel like time has been flying by. So quick introduction to the team for anybody that's new. We've got 6 members of the community on the planning team. All shown here. We actually just recently added Jomar. I know he's going to be here, so we can give him a welcome when he shows up. But we've got Bruce, Jomar, Eric, Steve, Tom, and myself. And together we're just, work on trying to find content, figure out how to plan things, figure out locations when we're actually in person. Things like that. Then we also have a few NI folks that help us along the way. Jed, who I'm sure most of you are familiar with, who's on right now, as well as Tom. And then Nilsson is remote sales support as well, or has been. Eric has some additional NI masks that he's willing to give away. So if you want a branded NI face mask like the one shown here, you can just contact Eric Schleeper through his email, or you can just reply to the user group notification emails, and I can make sure that your request gets to Eric. Eric, how many do you have left? Do you know off the top of your head?
I don't know off the top of my head, but there's plenty.
Okay, plenty. So if you want one, you can probably get one. And then, yeah, you just want to talk to Eric to figure out how you can pick one up. If you are not part of the mailing list, definitely make sure that you copy down the email address at the top here, info@choosemc.com. The mailing list will give you all the information about when a user group meeting is, what the links are, if it's an online meeting, or locations and whatnot for future meetings that we'll actually have in person again. And then occasionally we also send out extra information for activities, LabVIEW related, either certification or events that might be useful. But overall, it's probably only like 3 emails a quarter, so we do not flood your email. So definitely make sure that you sign up to make sure that you know about all of our future meetings. Okay, we have some changes to the support model, actually that are already starting to happen. Tom, are you here?
I am.
Great. Can you explain?
I'd be happy to. And I wouldn't necessarily say this is, it's more changes to our sales model more so than support. But in general, what we have decided to do in 2021 is go to what is referred to as an omni-channel sales and support model. And what that means is that we've determined that for a large swath of customers, our interactions with them on a sales side for sure was very transactional, where they would request a quote, place a PO, or go online on ni.com and buy it with like a P card or a credit card or something like that. What we've done is we've enlisted distributors to work with us. Newark is one of them. Test Force is another, and DigiKey. And so, for a lot of our broader based customers, if you would, we're trying to direct you to interact with those distributors instead of directly with NI. And in many cases, with respect to DigiKey or Newark, most of our customers already have relationships with those companies. Maybe actually have relationships with the salespeople from those companies. DigiKey is an online only, but Newark and Test Force are definitely more traditional. If you want to talk to somebody, usually there's a salesperson assigned to the account. The way they stratify accounts is a little bit different than NI, but in any case, if you want to buy directly from NI, you can still do that at ni.com. And if you want to use a PO and enter it there, if you know what you want, in many cases, most of you do already, you can buy it on ni.com, or you can get it through Newark or Test Force. Test Force has, I'd say, probably more technical salespeople to work with if you need help trying to figure out system configuration or something of that nature. So, but I think most everybody should have been notified by now of this change if you were going to be impacted. So, and if you got any questions, I'd be more than happy to try to answer them. All right.
Looks like you've answered everybody's questions.
Or nobody cares. Or they haven't bought anything yet this year, so maybe that's the case.
Yeah. So what would you say is the expected course of action someone should take if they have a question about like what hardware they should purchase, for example? Is that something that they should just be calling Newark or Test Force directly and they're supposed to get help that way, or what's the recommended way?
Yeah, behind the scenes, we're actually helping those two organizations stand up their ability. In some cases, they have actually hired some former NI people that were impacted by a layoff late last year. So, they're standing up teams with knowledge of our hardware to be able to assist customers as they're trying to determine what their needs are and things of that nature. And what I understand is, Test Force is a distributor that's a little more focused on test, where Newark and DigiKey are kind of more broad based distributors. So they may not have as the level of expertise you need, but I think each and every one of them are trying to stand up the ability to support you as you're trying to look at what your needs are.
Okay, cool. Thanks for the update.
Sure.
All right, we are going to try a quick survey here to kind of see how everybody's doing and just sort of get an idea of everybody that's here at the meeting. So if everybody could pull out their mobile phone or their just a web browser and go to this link. We're going to have a quick set of like 5 or 6 questions in order to poll everybody and kind of see where we're at. And then we'll move on to the actual sessions. So I'll leave this up here for just a little bit before switching over.
I don't see the link. Is it in the chat or what?
The link, do you not see my shared screen? The slide that says quick survey? I can put it in the chat too, but it should be on the screen right now. If you don't have the link, check the chat. We're going to switch over. A second here. Ooh, we've already got a bunch of results. Cool. Awesome. All right. So our first question was, what is your primary industry? Looks like we're still getting some results coming in right now, but a lot of us are NI partners, which is great. Some academics, electronics, good amount of biomedical. Awesome. What are the others? It's a big enough proportion here. If anybody wants to explain what their other is.
I'll bet you that's retired.
That works. All right, let's move on to the next question. What are your full-time equivalent years of LabVIEW experience?
I like that we can see this in real time.
Yeah. Cool. We've got a lot of pretty experienced people. That's awesome. This is the first time we've really done a poll like this, so. Cool. Are all votes in? I think last time we had like 26. Nice. Cool. Okay. So a few new people in LabVIEW, but quite a few experienced folks. That's great. All right. Now you have the experience, but how often do you actually use LabVIEW? Like right now? Okay, nice. So we've got people across the board, but so LabVIEW, I'm guessing this means that LabVIEW is part of somebody's responsibility as opposed to their full-time responsibility a lot of the time. So you might be an engineer working on a lot of different things, but then writing LabVIEW as part of accomplishing or completing those projects. Neat. All right. A few people that is just sort of not less than an hour a week, but glad you're here. All right, next. This is more pandemic related. How many people are still working from home? Okay. So some people are moving maybe half-time, but quite a few people are still working full-time from home. And a few people are working too much, is what it looks like here. Sweet. All right. Pandemic's impact on your business. Yeah, this is really close to what I've sort of been observing, especially in the technology industry. Seems like it's either been a little bit better or a little bit worse for a lot of people, and then there's a few others out there that it just really either hit really hard or just because of the nature of their business, it's helped them tremendously. So this is interesting to see. Cool. So hopefully all these slightly bads will start ramping up in this next year. All right. So this is kind of similar. When did or do you think we will see an upturn in the economy? All right, so looking like people are thinking third quarter or after, huh? All right. Cool, well, it's good to know. Yeah, I'm really curious to see how the reopening process happens depending on vaccine prevalence and how the different strains are handled by those existing vaccines. So it'll be really interesting to see if we can bump that into Q2 or if it's really going to be Q3 and 4. All right. Who wants to start the presentations? Wow, all right. 50-50, mile more than 50. Cool, we can do more surveys later, you know. Next quarter. Would people like to repeat this? Kind of get more of a feel for the landscape in our area? Should have added that as a... We'll do that now.
I thought you might get a question about how many people had been vaccinated, you know, so we could figure out whether we can start meeting in person again one of these days.
Well, let's do that real quick.
Oh, can you create new questions on the fly? This is new technology. I have not done this before.
Let's see. Yeah, let's are you vaccinated?
That's a no, but my appointment's for tomorrow.
Oh, nice. Okay. Well,
I'll be interested to see how this question changes if you rerun this again in 3 months.
yeah.
Probably a pretty good indication of the age of the group right now.
Hey, can you ask the question, how many people plan on getting vaccinated?
Have already or plan to.
All right.
I'm half vaccinated.
I think that counts. All right. So, I mean, 36% is pretty good, though. And this is anonymous. There's no way for us to track you. The government didn't put us up to this. Great. No, that's really good to see.
All right, good to know. So,
all right. So then, quick last question is: should we repeat surveys like this next time? Just send them, reply to the newsletter email, and then that'll reach me, so I can add them, and we can ask them next time. Cool. All right, this is a neat experiment. All right, let's get going with our presentations. Darren, are you ready?
I'm ready. Let me share my screen. You guys see my screen?
Yep.
Awesome. All right. Well, although I just participated in the surveys, and it sounded like roughly half of you would have rather continued answering questions than hear me talk about LabVIEW. So sorry to disappoint y'all. Also, it sounds like in that survey, about 2/3 of y'all have been programming in LabVIEW for 10 or more years. So hopefully, most of you are familiar with the concepts I'm talking about in this presentation. But nevertheless, I hope it gets you thinking about some things that maybe you hadn't thought about before. So if everybody can mute their mics, I'll go ahead and get started. My name is Darren Nattinger. I presented to you guys before. If you haven't met me before, I work at NI. I've been at NI for 22 years now. I was in LabVIEW R&D for most of that time, but last year I moved into the tech support group, which is where I'm currently at. And this presentation I'm giving today, best practices for error generation and propagation in LabVIEW. I originally gave this at NI Week a couple of years back. I have updated the slides a couple of times since then. The most important change, of course, being the fact that they're all green now. So you're welcome, everyone. We're now green. We're no longer blue. So before I get started on the content of the presentation, I wanted to point out that this material is already available for download on ni.com. You can go to bit.ly/dnaterrors, and you can download these slides, and there's also a link to a video recording there as well. Also, before I get started, I want to thank one of my colleagues, Stephen Loftus-Mercer. Some of y'all probably know him. He is a brilliant individual in LabVIEW R&D at NI. He is the world's expert on error generation and propagation in LabVIEW. I am a distant second place, so sorry y'all aren't getting the expert, but yeah, hopefully you're getting the next best thing on this topic. He helped me put together a lot of the materials in this presentation. As I'm going through here, I definitely have less than an hour of content, so if you have any questions for me, unmute your mic and ask, or post in the chat. I'll try to glance over there every once in a while and see if there's anything there. So this presentation is about error handling, right? Well, that term is actually kind of a bad term. I try not to use the term error handling anymore. After getting taught about this topic from Stephen, he pointed out that if somebody's talking about error handling in LabVIEW, they probably mean one or more of the terms that are on the slide here: error generation, propagation, response, display, and logging. If someone says, hey, I'm working on the error handling for this application, they might be referring to one of those things, and it's not immediately obvious which one of those things they're referring to. So I have stopped using the term error handling, and I try to be more precise. I try to pick one of these 5 terms on this slide instead to be more specific about what I'm dealing with when I'm talking about errors in LabVIEW. Now, this presentation, I'm going to be talking about error generation and error propagation, but I don't want to leave the other 3 topics behind. So just for a minute, I'm very briefly going to talk about error response, error display, and error logging. Error response. Error response is what you do when there's an error that occurs on your block diagram, and you look at that error value in an error wire and you respond to it in a certain way. You might ignore that error. It may be an error that you don't care about. You might retry something, so you've got a loop that's keying off of whether or not an error happens. You may take an error code and translate it into a different error code just for whatever reason, just to make things easier for the end user of your application. There's many possible ways to respond to an error value in an error wire on a block diagram. Now, the reason I'm just doing a quick overview of this is because Stephen put together a poster that has every possible way you can respond to an error. If I was giving this presentation to you guys in person, I would have a big stack of these and I would be handing them out. That's what I did at NI Week a couple of years ago. Everything's virtual right now. So I've got a PDF that you can download on ni.com to get this poster. And the thing about the poster you need to know is Stephen designed this poster several years ago. Everything on it is still accurate and correct, but there's a few changes in error propagation on LabVIEW block diagrams that have happened since then. For example, if you look at this poster, you won't see the clear errors VI being used to clear a specific error. That's because Stephen made this poster before we added that to that VI. So just keep in mind, if you see some patterns on the poster and you think, wait, why didn't he use clear errors there? It's because we didn't have it when we made the poster. All of the sort of semantics in that poster, though, are still relevant today. So go download that PDF at bit.ly/dnaterrors. That's all I'm going to talk about for error response today. Next up, I'm going to give a quick overview of error display. That simply means that you want the end user of your application to know that an error has occurred. And by the way, thank you for whoever just posted the link to my presentation in the chat there. So that's where you can go quick and get that stuff. But anyway, error display. You are almost always accomplishing error display with a simple error handler VI or a general error handler VI. And I hate the names of those VIs. Now that I've decided I'm not going to use the term error handling, right there, I've still got that staring me in the face that we call these VIs simple error handler, general error handler. Should probably call them simple error display and general error display to be consistent. But anyway, most of the time for error display, you're using those two VIs. Now, you may have some application you've written where you want to present error information to the end user of your app and you do not want to use these VIs. One thing that you can do to sort of help you with that is the error handler VIs, you can wire in a type of no dialogue. And when you do that, the VI is not going to pop up a dialogue like it normally does, but it will return to you the string that it would have displayed as a message if it had popped it up. So if you're designing your own error display and you want access to the user readable error messages that would normally be generated by the error handler VIs, you can use this trick here that I show on the slide. No error, or I'm sorry, no dialogue, and then get back the string and then do with it whatever you need to do for error display. All right, that's all I'm going to talk about for error display. Now for error logging. Error logging is the sort of what you have to do for an application where you've got your application running and you want to take errors that happen and you want to log them. Maybe there's non-critical errors where you want the application to keep running, but you still want to know about those errors, so you log them to a file. This is an incredibly complex topic. So complex, we spent an entire CLA summit talking just about error logging several years ago. I'm not going to talk about it today. There's lots of information about error logging frameworks that people have written. You can go Google and find that stuff. The only thing I'm going to say is when you're working on error logging, there's a couple things to keep in mind. You want to log all errors, even the ones that your code handles, because it's still useful to know that they occurred. And it's a good idea for your error log to periodically sort of have a heartbeat in it that, you know, hey, no errors happened, everything's still going fine. And that's because if something goes wrong with your error logging scheme, unless you're keeping some sort of heartbeat, you may assume that no errors happened, but in reality, your error logging wasn't actually working and it's not logging anything. So keeping a heartbeat in the log is useful for knowing that everything's still working okay. All right, so yes, error response, error display, error logging, all aspects of error handling, but all things that I'm not going to cover in detail in this presentation. Instead, before I talk about error generation and propagation, I want to give you a warning about warnings. And my warning is that you should not use warnings. Warnings are, it's kind of like having a light switch in your office and you've got the on and you've got the off. What if there was a third one that was kind of in the middle? What does that mean? If I flip my light switch to the middle, wait, is it on? Is it off? That's exactly what warnings are. Are they errors? Are they not errors? Should I care about them? I mean, they're being returned to me. I'm being told about something. Is this something I need to worry about? I really don't like that ambiguity, which is why I always suggest to people when you're creating a new API in LabVIEW, do not include warnings. All that being said, unfortunately, there are several APIs in LabVIEW that include warnings, like, oh, I don't know, a little one called DACMX you may have heard of. So there's APIs in LabVIEW that have warnings. We have to deal with them. And because of that, you want to make sure that your code is aware of warnings. So when you're writing your own G code, don't ever generate warnings, but you might be using APIs that do. And when they do, make sure you do not write code that looks like this block diagram. I see this code everywhere where people go into like the no error case of a case structure and they say, well, it's no error, right? So I don't need to bother wiring the error coming in because I know it's not an error. The thing is that case structure is going to run this case even if there's a warning on that error wire, which means you will lose that warning at that terminal. So if you have something you need to know about a warning being returned by DACMX that's upstream from this code, you would lose it at the point that that arrow is pointing to on the diagram because you did not wire the error wire through on your diagram. And I have a lot more to say about error propagation later in this slide. This is an example of a place where the error wire is not being propagated properly, and as a result, any warnings might be lost at that terminal. So make sure your code is warning aware, even though I'm telling you, don't create your own warnings in any of the code that you write. All right, let's start talking about error generation. So remember, error handling is a bad term. We don't know what it means. It could mean anything. It could mean error generation, which is what I'm talking about right now. And that's when an error value is created at some point on a block diagram and it starts to flow through a stream of error wires. All right. There are only two ways, believe it or not, that errors can be generated in LabVIEW. The first way is a built-in function, like a file IO function or a visa primitive or a property node or a call library node. Those are built-in nodes in the LabVIEW language that can return an error value on their error output terminal. That is one way you can generate an error in LabVIEW. The only other way is if you write G code yourself that generates an error value. A lot of the times when people use call library function nodes, they need to take a numeric error code and turn it into a cluster. So what do? They write G code like what you see in the picture on the left, where they use the error cluster from error code VI to create an error cluster value that has an error on it. The other way that people will create error values is with the error ring, which I'm going to talk about in more detail coming up in the slides. Error cluster from error code, though, very handy VI if you've got something that will generate an error number, and it just is the number and nothing else. This is incredibly common with call library nodes, like I talked about before. So when you use error cluster from error code, there's a few things to keep in mind. The first thing is you always want to wire the error in terminal with the upstream error from whatever code ran before this. And that's because you want to preserve any previous error that may have happened when from upstream code. Another thing you always want to do, this VI has show call chain defaulted to false. That's not useful. The call chain is an incredibly useful thing whenever you're debugging your LabVIEW code. So you want to wire a true to the show call chain. The only exception is if you're on something like LabVIEW real-time, where any little thing might introduce jitter. Getting the call chain from a VI is an example of something that could introduce jitter on RT. So that's a place where you may want to wire a false. And one of the reasons I like this VI is because since I'm using this VI, I am writing the LabVIEW code that is called before this VI. I have the power as the LabVIEW developer to include useful information along with the error cluster. And I can pass that in through the error message string input on this function. Now, one thing you don't want to do, and I see this everywhere, is build the error cluster yourself. And again, the exception, if you're on like RT or FPGA or some weird situation, I'm talking about regular desktop applications. Don't build the error cluster yourself. I see code like that picture in the bottom right all the time. I see a hard-coded VI name going into the source string. And then somebody, does a save as on the VI and saves it with a different name, and they forget to go in and change this. So now you're trying to debug your code, and there's a VI name you've never heard of. It's the source string for an error cluster. That's just one of many reasons why this is a bad idea. Don't build the error cluster yourself. Always use the error cluster from error code VI on this slide, or the error ring. I love the error ring. This is an incredibly useful tool for doing proper error generation on your block diagrams. We've had it for several years now. I think it was introduced in around LabVIEW 2012 or so. And what it does is it lets you interactively sort of configure what an error value is on the block diagram. It also lets you include the call chain. But one of the coolest things about it is that you can include format specifiers. So when you create a custom message, the error ring actually gets terminals that you can wire data into that are included in the error cluster source string information. Now, when you use the error ring, you probably are going to want to use custom error codes. There are a lot of error code ranges that NI APIs use. Like if you use DACMX, it's going to use a certain range of error values. If you use NI Visa, it's going to use an incredibly annoying range of values that are like negative 100 million, right? Well, there are some error code ranges that NI guarantees that we will not use for any of our products. And those ranges are shown on the slide here. So when you are generating custom errors with the error ring, like I'm going to show in the next slide, pick a number that is in those ranges. You probably want to pick a certain range within those ranges and use that for certain APIs that you write or certain aspects of your application. And when you do this, you probably want to create error code text files. I'm not going to go into detail about those in this presentation, but in LabVIEW, there's a tool, Tools Advanced Edit Error Codes. You can click the Help button on that tool to learn more about what error code text files do, but it's basically a way to include your own custom error codes along with built DLLs and built EXEs so that those error codes are properly displayed to end users of your application. So here is an example usage of the error ring. So first of all, I always recommend that the error ring be put in a case structure and only called whenever you actually need that error value. And the reason is that the error ring is going to cause some code to execute to calculate the call chain. And that code, you don't need that to run if you don't need the error value. So I've got it in a case structure. I'm merging it in with the upstream error, which is always the best practice in terms of propagating your errors properly. And check it out. In my application, I've defined the custom error code of 8001 to be the specified operation on the file is invalid. And the error ring allows me to include those %s specifiers in the error text. And so what I can do is I can give the end user of the application the path that they tried to operate on and the operation that they tried to do on that path. So instead of just seeing the text, the specified operation on the specified file is invalid, I see that kind of text and errors all the time. And it's infuriating when it doesn't tell me which operation and which file caused the error to occur. That's why you can generate these error values with your own LabVIEW code to basically say, aha, I'm going to give the end user as much information as possible when I give them this error so they can try to figure out what the problem is. I see a question in the chat about why not build your own. Yes, you're right. The call chain is an easy way to handle that. Also, honestly, I really like not having to drop the format into string function on this block diagram and wire it all up with these things I want to pass along with my error cluster value. By using the %s specifiers in the error ring configuration, I can, the error ring inside of it that handles all that for me. And all I need to do is pass in the things that I want included in my text. So that's just a couple of reasons why I think the error ring is great. So a couple of other usability tips for the error ring. Again, always include the call chain if you can. Also, you may not like just how big and fat the error ring is. It takes up a lot of space on your block diagram. You can turn off the explanation text if you want to save space, and that'll make the error ring super small and compact. And then another thing I do is I will create VIs in my project that wrap certain error rings that are set for certain values. For example, the one in the picture at the bottom of the slide, error 5002. Sometimes it's useful for me when I'm debugging an application to find all of the places in my application that could possibly generate a particular error. That's when wrapping error rings in sub-VIs comes in really handy, because all I have to do is search for that sub-VI throughout my application, as opposed to searching for error rings. Unfortunately, you cannot do a text search in LabVIEW and search for text within an error ring. So just doing a text search for 5002 would not find me these error rings. And that is a feature request on the LabVIEW ID Exchange right now. So R&D is aware that that is a need, but we don't have that right now. So in order to make it easier for me to find certain error rings in my project, I always wrap them individually in sub-VIs. So it's very easy for me to find all the places I might generate a particular error. Any questions on that before I keep moving on? Let's move on to error propagation. This is the meaty part of the presentation. This is where we talk about where you have an error value and you move it through your LabVIEW code. There's a lot of aspects to propagating errors. You might have an error wire that you fork to start parallel code paths. And then similarly, you might have some parallel code paths and you need to merge the errors that are generated by those. You may wrap some code in a case structure and have that code not execute whenever an error occurs. So we're just going to pass the error through. There's many aspects to error propagation, and there's many tools on the LabVIEW block diagram to facilitate error propagation. Like I said before, the case structure, the merge errors function, shift registers on loops. But there is one and only one overarching rule for error propagation on your block diagrams. And that rule is that you should never, ever break the error chain. Here's the thing about LabVIEW. Sub-VIs and functions on your block diagram, they're religious. I don't know if you knew this or not, but they're religious. They believe in a higher power. Those sub-VIs you see on that block diagram, they believe in a higher power, and that higher power is you. They have faith that you will shepherd any error they generate to its final resting place. So in any one of those sub-VIs you see on the screen there, it believes in you. It believes that, I'm about to generate an error, something went wrong. The LabVIEW programmer is going to make sure that this error makes it to wherever it needs to go. It might be going to a general error handler VI for a pop-up. It might be going to some sort of error logger. It may be going to an error indicator on the front panel, but it believes, hallelujah, it believes in you, that you will get that error to where it needs to go. All it takes is one place in an entire VI hierarchy that breaks the error chain. And that one place will cause any node's upstream error generation to be lost forever. Now, probably not forever, because you probably own the code and you're going to spend the hours of debugging necessary to go find the place where that error that's causing an issue is mysteriously not being reported because the error chain has been broken. Now, there are several different ways you can break the error chain in your LabVIEW code. This is the most important part of this presentation, by the way. This is where I'm going to talk about all the ways that we can screw up the error chain and screw ourselves in the process by not being able to debug our applications properly. So if you pay attention to any part, pay attention to the next few slides. So the first way that we can break the error chain is simply forgetting to wire an error, just like in this picture right here. We start the DACMX task, we do the DACMX read inside the loop. Once the loop's done, we stop the loop and clear the task. But we forgot to wire the error cluster from the loop to the DAC stop. So if there was an error on the start, or if there was an error on the read, we would not know about it because we forgot to wire that error. This situation right here is very difficult to debug. Take it from me, because I have had to do it. With an application with a deep hierarchy, hundreds of VIs, thousands of VIs, something goes wrong, but you don't know what it is because you don't have an error. And that's because somebody forgot to wire one right here. Now, we have a couple of tests in the VI analyzer that can detect this issue. First is the unused code test, which would detect what you see on the slide here, where there's a tunnel that's leaving a loop, but it's not being wired to anything. We also have the error cluster wire test that will tell you when a sub-VI or a function does not have its error output wired. Also, if you use automatic error handling, which I will also have some more things to say about later in the presentation, that is one possible way to be able to determine when this kind of situation takes place. I see a couple of comments in the chat over here. One common way to break the error flow is to automatically generate a sub-VI. The connector has the error in and out, but the diagram is not wired. Okay, I can see that. And then Bruce is asking if the desktop trace toolkit detects this. The desktop trace toolkit can detect if there is a function that generates an error, but that error is not wired. It basically can give you the same functionality that automatic error handling can give you. Correct me if I'm wrong, but I don't think the trace toolkit can detect what you see on the slide here, where it's a tunnel where the error is lost, as opposed to an actual function or a sub-VI. If it does, that's great, but I don't think it catches what you see here. All right, another way to break the error chain. This is an incredibly common thing that I see in code, which is zero iteration for loops. Now, again, 2/3 of this audience are LabVIEW programmers of 10 years or more, according to the survey. So you guys know what happens with tunnels on zero iteration for loops. For those of you that don't, the reference output and the error output of that for loop are going to return a null reference and a no error value if that for loop runs 0 times, regardless of what the values were that came into the input tunnels of that for loop. For loop output tunnels return what are called default values if the loop runs 0 times. Now, you've probably heard the term default value, right? If you've never heard the term default value, that means the default value for a given data type. For example, the default for numerics is 0. The default for Booleans is false. The default for strings is empty string. So in the case of this diagram, the default for a reference is null reference, and the default for an error cluster is status false, code 0, source string empty. So this code right here is an example of a way that we could break the error chain. If there is an error coming into that for loop and then the for loop runs 0 times, we will lose that error whenever the for loop returns the default for the error cluster. The way to solve this, which Will mentioned in the chat, is to use shift registers instead of tunnels. So on a for loop, if you replace those reference tunnels with shift registers, and if you replace those error cluster tunnels with shift registers, then if that for loop runs 0 times, whatever value went into the left side of the shift register is the same value that gets output on the right side of the shift register. So always look for loops on your block diagram that could run 0 times. We have a VI analyzer test that can find this. It's called for loop error handling. It can find this exact pattern. Your main takeaway here is that every single time you implement a for loop on a block diagram, and I know that's a lot because for loops are the second most common object you will find on a block diagram. Case structures are the only thing that's more common. So we use for loops a lot. And every time you implement a for loop, you need to ask yourself, is this loop ever going to potentially run 0 times? And if it does, am I handling errors and propagating them properly if it does run 0 times? You have to ask yourself those 2 questions for every single for loop that you create on a block diagram. Now, what if you don't want to use a shift register for the error? What if you want your for loop to execute regardless of if a previous iteration returns an error? Like this for loop here, or let's go back to the previous slide. Let's say I replaced those error tunnels with shift registers, and let's say that for loop ran 100 times. And let's say on iteration number 10, the TDMS write returned an error. But let's say I really wanted to write all the rest of that data to the file, even if an error occurred. Well, if I used an error shift register, no iteration after that one where the error happened would do anything. All of them would just pass the error through. And that might not be what I want. What I might want is something more like this, where regardless of if one of the iterations generates an error, I want all of the iterations to write the data if they can. So then you would write code that looks like this. We can't use the shift register because the one iteration that returns an error would return it for all future iterations. So instead, what you can do is build up the errors on the tunnel of the for loop and then concatenate those in a merge errors function. If your loop is going to run a jillion times, you don't want to build up a jillion error clusters on that tunnel. So you might just add some logic where you just store in a shift register the first error that happened or something like that. Once the loop's done, you can wire an array of errors into the merge errors. And one thing to watch out for, which will come up later in the presentation, you want to make sure to merge in the incoming error. Why? Because that for loop might have run 0 times. And so you want to make sure that even if it runs 0 times, you are still propagating the upstream error from before the for loop ran. Now, we have parallel for loops in LabVIEW, which are really cool. And this pattern that you see on the slide here is how we would recommend you do error propagation for a parallel for loop. In case you've never seen that little thing on the border of that for loop before, that is called an error register. That was added in LabVIEW 2018. That error register on that parallel for loop effectively does exactly the same as what you saw on the previous slide, just under the hood. It builds up the errors generated by all the parallel instances of the for loop diagram and then merges them all at the end. And what this does is it allows your parallel for loop iterations to run in parallel, which you couldn't do if you had an error shift register. And then it merges them all on the output tunnel. In LabVIEW 2018 and later, you can't even create an error shift register because it automatically turns into an error register. All right, pop quiz. This is the only quiz question in this presentation. Somebody tell me, who hasn't seen my presentation before, what is wrong with the error propagation in this VI? Somebody has to say something before we continue. There is something wrong with the error propagation. Tell me what it is. David in the chat says error priority is inverted. Bruce says the first merge is backwards. I don't know what we mean by first merge. If we mean on the top level diagram, then you're correct, Bruce, and David, you're correct. The problem is where this red arrow is pointing. So we want to make sure that when we propagate errors in LabVIEW, we always return the first error that happens. The reason is that if if an error happens, and we can't guarantee what's going to happen downstream from that. So an error has happened. Who knows what kind of crap went wrong after that? We'll probably get a bunch of errors after that too. The important error is the first one. And as we can see on this block diagram, the error into this VI, whatever happened upstream from this VI, is not the top input of the merge errors function that the red arrow is pointing to. So what that means is if we have an incoming error to this VI and that sub VI in the upper left corner of the diagram generates an error, that sub VI's error is going to be the one that makes that out of here. That's not what we want. We want the upstream error from this whole VI to be returned, which would be the error in control. That should be the first error input to the merge errors function. You got to watch out for sloppy merge errors ordering. Make sure that whatever happens upstream is always the top input of merge errors, because that is going to be the input that is prioritized whenever you have multiple errors going into a merge errors function. So to summarize the most important part of the presentation, which is avoiding breaking the error chain, the error cluster wired test in the VI analyzer, again, detect sub-VIs and functions with unwired error outputs, and it provides options to ignore certain objects where we, a lot of the times, don't wire the error outputs. We've also got the unused code test in the VI analyzer that'll detect things like that very first picture I showed where we didn't wire the error output from the DAC loop. Then we've got the for loop error handling test, which detects possible problems with error propagation with loops that run 0 times. And then this last bullet point here, I included this as a concession to Stephen, who helped me put this presentation together. I am not a fan of auto error handling. Stephen is, and he suggests that one way to avoid breaking the error chain is to have auto error handling turned on during development of your project. When you do this, you kind of need to assume that all the error conditions are tested during development. And you also have to write tooling to turn auto error handling on and off for the entire code base. So I'm not interested in doing all that stuff, so I don't use auto error handling, but that is something that he asked me to include as a possible way to avoid breaking the error chain by using automatic error handling as a development tool. So for those of you who have not read the release notes for LabVIEW 2020 yet, there is a pretty interesting new feature related to error propagation in LabVIEW 2020, which is the ability to retain multiple errors on a single error cluster. So you can see here we have 3 parallel code paths, one that's doing file IO, one that's doing TCP, and one that's doing data type checking. All 3 of those generate an error. Now, the merge errors function normally just passes out the first error that it receives in top-down order. But there's a new right-click option in LabVIEW 2020 on the merge errors function where you can set it to retain all errors. When you do this, merge errors still outputs just a single error cluster. However, all 3 errors that came into that function are now encoded into that single error cluster in the form of some JSON that's stored in the source string of the error cluster. So now you have a single error cluster with multiple errors on it. You can then use that VI that's shown there, error cluster to array of errors, which will then split out all of those errors into individual error values, and you can see them shown here on the slide with the JSON that's inside. So again, this is a brand new feature. I don't think it's gotten much use out in the field yet, but I wanted to let everybody know because this is a long-standing request to be able to sort of multiplex errors in this way. LabVIEW NXG had this feature, and we thought it would be good to have in LabVIEW as well. So if you're interested in using that for any new sort of error propagation schemes you're working on, know that that is a feature available in LabVIEW 2020. All right, so why do we do this whole error case structure thing? We wrap our code in an error case structure. So many sub-VIs that we write, this is something that I do as well. We wrap the code in an error case structure, but let's stop and think about that. I mean, that's what this presentation is about, right? Let's stop and think about the error propagation of this block diagram. So we've got those three functions down there that are doing a list folder, right? And those, let's say that first one gives back, it returns an error, or let's say an error comes into this VI, right? So if an error comes into this VI, then all three of those functions are going to return an empty string array as their outputs. And that is going to result in that top for loop running 0 times and passing through the empty string array. It's going to result in that build array down there building 2 string arrays that are empty into 1 string array that's empty. And since those functions just pass through an error input and don't do anything and pass it right back out, whatever error in came into this VI is going to be passed out to the error out. So this diagram does not need that case structure around it because it is going to function exactly the same with an error condition with or without that case structure. So we need to stop wrapping every single VI in an error case structure. As we know, all errors, as we talked about at the beginning of the presentation, all errors are either generated by built-in functions or by G code. Almost all functions in LabVIEW will skip execution on incoming error. The rare exceptions to that are things like close reference or close file, close or destroy type functions that are going to execute regardless of whether there's an error input. And as I just illustrated with this diagram, with rare exception, the block diagram is going to function as expected with an incoming error with or without that case structure that wraps the diagram. Now, there are some instances where I think it makes sense to use an error case structure. The most common one is that if your code is manipulating the error stream in some way, you probably want to wrap that code in an error case structure so you don't inadvertently manipulate an error cluster that's coming into this VI. In a couple of other rare cases, your code may need to output some non-default values if there's an error. Another very rare case, your code might execute for a long time, whether or not there's an error condition. So you want to make sure it doesn't execute if there's an error condition. But what I end up doing is I end up documenting the code whenever I do use an error case structure, just to let the person know reading this diagram, which is often me, that it wasn't just a brainless error case structure. I put it there for a reason. The picture on the left shows using an attached comment on the error wire. The picture on the right shows a case structure label that I colored as green. I have started using the picture on the right more and more because I think that it is a good way to self-document the code. Like when I open a diagram and I see that green label on the case structure, I know, okay, whoever wrote this diagram put some thought into why there is that case structure around it. Now I see Steve's comments here in the chat here. Someone doesn't have to analyze all the details to see that it won't do anything. Yes, but I will fall back on another point that I make in another presentation I give, which is every single time there is a decision point on a LabVIEW block diagram, there are optimizations that the LabVIEW compiler cannot do. The LabVIEW compiler is super smart, super good. It does its best job to make your code execute as fast as possible. And there's a ton of optimizations that it has. Every single time there's a decision point on a block diagram, whether that is a case structure selector terminal, whether that is a select function or something else, there are a lot of compiler optimizations that LabVIEW can no longer do because there's decisions that have to be made on that diagram. So I tend toward let me see what decision points I can remove from my block diagrams to improve their ability to be compiled into faster code. That's the main reason that I look to remove all of these unnecessary case structures from my block diagrams. All right, so let's talk about wiring error output. Look at all the functions on this picture here, and sub-VIs, and property nodes, and invoke nodes. They all have error outputs. Every single thing on this. Did you know that a subtract function can have an error output? There it is, right there on the slide. Pretty weird, huh? In case you're curious, if you wire waveforms to the math primitive, they get error terminals. We call those Pac-Mans in LabVIEW R&D because it kind of looks like a Pac-Man. Anyway, look at all these things with error terminals on them. Do we have to wire the error output of every single one of them? Now, I have colleagues who would tell you yes. I'm telling you no. If you know that there is no way a function can reasonably error out, it is a waste of time to wire its error output. Look at that format into string function there. It's got a number and a string coming in and a %d and a %s in its format specifier. There is no way that function will ever error out. It's a waste of your time and your block diagram space to wire the error terminals on that function. Similarly, the picture on the bottom, I've got a file I want to delete. I've got a reference I want to close. And if I can't delete the file, no big deal. And if I can't close the reference, no big deal. I don't care about the error outputs from those functions, so I don't wire them. Now, I mentioned before the error cluster wire test in the VI analyzer. It has a bunch of options to ignore these type of functions. And I typically have that test configured to ignore all of those. I have colleagues who have that test configured to check all of those. So it's a personal preference thing. All right, so just coming back to the auto error handling thing, I am not a fan of the feature. I tend to feel like it's babysitting me as a LabVIEW programmer. I wire the error terminals I care about. I ignore the ones I don't, and I don't need the editor telling me which ones I chose not to wire. So in my opinion, auto error handling should be turned off. There is a VI analyzer test you can find if you Google for it that'll turn off the setting on all your VIs. I think that code looks silly when someone dangles the clear errors VI or an empty flat sequence off of outputs of functions just to disable auto error handling. I have plenty of pontificating I do about this topic. You can check out my Brainless LabVIEW presentation to hear more about that. So Will asks in the chat, you would need to turn off auto error handling for that to work, right? The not wiring errors on functions that output. Yes, I already answered that. Correct. I have automatic error handling turned off. That is why I don't see those errors. Or, well, I would never see an error on that top one, and I don't see the errors on the bottom ones because I have auto error handling turned off. That's right. All right, so a few closing thoughts on error generation and propagation. You need to make a conscious decision about every error wire you create on your block diagram and every error wire you don't create on your block diagram. The key that I hope you're taking away is that you should be able to look at a block diagram and know exactly how that diagram will function with an error condition based on the patterns I described in this presentation and good code documentation. The problem with auto error handling is that there's no way to know if a VI is going to pop up error dialogues or not without viewing VI properties. It's kind of like a hidden feature, which is why I really, work strongly to get that turned off on the project that I worked on, just so there's not random stuff popping up. And the error chain on a block diagram should be immediately obvious. Every diagram you open, it should be immediately obvious how the errors are being propagated through that diagram. And I have a question from Eric in the chat. What do you do about errors you only wish to display once? Eric, I assume you're referring to like if you've got a loop that could generate an error and you acknowledge that error, then the loop runs again and it can generate the same error. Is that what you're talking about? If so, that's kind of, I would say that that's an error response sort of thing, which is the patterns that are described in that poster I referred to earlier on in the presentation. There are error response patterns for respond to an error and ignore later, and that kind of stuff is covered in there. Mark mentions that it's important to test how your code responds to errors. I absolutely agree. I've written a whole lot of unit tests in the past that you give a sub-VI an expected error condition and make sure it generates the error you expect it to. Any other questions or comments from anybody? Steve's got a suggestion there about the errors you only want to display once. Yeah, I'm pretty sure that pattern is described in the error responses poster. Anything else, anybody? All right, well, that's all I have. bit.ly/dnet errors is where you can get these slides and a video and the PDF of the error responses poster that I talked about before.
Thanks a lot, Darren. A lot of good information. I think I actually did not know about the retain all errors right-click option. So
yeah, that's a new one in 2020. So we're trying to get the word out.
Awesome. Yeah, it looks really cool. Makes it a lot easier. Do we have any last questions for Darren? All right, cool. Well, Darren, thanks again. Really appreciate you presenting for us the second time. So it makes a big difference for us. I'm going to say let's take a quick maybe 3-minute break. We'll say 4-minute break. We'll start right at 3 minutes. There we go. We'll start right at 5:40. Jomar and Mark, does that work for you guys?
Yeah, that's fine.
Okay, cool. Go ahead and steal the presentation whenever you're ready to start. And we'll see everybody at 5:40. Jomar and Mark, feel free to start whenever you're ready.
All right, we are ready. So you can hear me?
Yep, can hear you loud and clear.
Awesome. All right, first I just want to say thanks again to Darren for that great presentation on the very important topic of error handling. Definitely something you want to think about as soon as you start writing your app. You want to start planning for error handling. It's better to do it up front than on the back end. All right, so we are going to shift gears here and talk about test stand deployment for a little while here. So normally we stick to LabVIEW topics, but we'll bring in some test stand now because that's gaining a lot of traction out there. All right, I'm Mark Ridgely, everybody. Good to see you. Good to be back in this forum. It's been a while for me since I've been here. I'm going to be presenting today with Jomar Ochoko, who's going to be the co-presenter. He'll come online a little bit later. But I am a certified LabVIEW developer, test stand architect, certified professional instructor, LabVIEW champion, and owner of Radius Technologies. I'm an independent LabVIEW and test stand consultant. And when I'm not doing consulting work, I do training for NI, doing a lot of virtual stuff lately. But it's a lot of fun getting back into the user group forum. It's been a while since I've been able to attend, much less present here, and I appreciate the opportunity. And today we have Jomar Ochoko. Jomar, if you want to introduce yourself.
Okay. I'm an engineer at Abbott. I was one of the few people that said that my company was doing much better with the pandemic. Yeah, so I'm a CLD and a CTA. And yeah, that's my intro.
All right, so Jomar's going to be coming back a little bit later in the presentation to present some real world examples of deployment and test stand. But for most of this presentation, we're going to be talking about the tools that test stand provides for doing deployment. So the agenda for this presentation is here. We're going to first define what deployment means and the different types of deployment that you may find yourself doing. We're going to then look at what should you deploy. Then we'll have some recommendations for best ways to handle the deployment. Talk about first steps that you take when you're getting ready to deploy. Choosing a deployment method, basically how you're going to actually physically deploy. Different types of deployment. Testing your deployment. Updating an existing deployment. Custom installers that you could create. Then we'll look at some real world examples and a common deployment issue. And then there'll be on the end some time for discussion. So deployment is defined here as the identification, collection, and deployment of all the components of the test stand test system to the correct locations on the target computer. So that's critical. And a lot of times you may not think about everything that needs to get deployed. But when you're doing a test system, it ends up being quite a bit of code and resources and whatever else you need. So definitely want to plan your deployment and execute on it well. So there's two types that we're going to look at today. The first one is the framework deployment. Now this comes more from the test stand architect's perspective. The architect is typically someone who's required or to do the framework of your system under which everybody operates. So if you're an architect, you're going to be deploying the framework to the test developers. The framework might consist of custom step types, templates, tools that you may develop, and you have to deploy that to your development team, and the developers use that framework to do their development within. The second type of deployment is test deployment. This is where the test developers create their own deployments for the tests that they actually write. So there are two types of deployment when you're talking about a system as an overall thing. This is going to compare the framework deployment to the test deployment. So you see on the left side, you have the framework architect. Again, they're the ones that are, defining process models, custom step types, templates, and tools. They have to deploy all that framework components to the test developers. And in the center of the slide there, you see you have multiple test developers, each writing their own tests. When they get done writing those tests, then they deploy the test, and that is a test deployment. Typically, that's the only part of deployment that people think about when they think about test stand. Oh, I just got to get my tests out there. But the other part, the framework deployment, is equally as important. So once you do your test deployment, then that goes out to your production testers where it's put into use. So what to deploy? Well, you're going to deploy all your hardware drivers, your user interfaces, and your test code, right? So that's everything that you should need to make a working system. We're going to take a look at each one of those in a little bit more detail in the next few slides. So when we talk about the runtime engines, you definitely have to deploy the test stand runtime. And then you want to deploy the runtime for any development environment that you might be using to create your code modules. And there's hardware drivers, things like DAC-MX, iMac, or any of the NI instrument drivers or any of the other drivers that you may need, even from third parties. But you have to get all that stuff deployed as well. Your user interface. Now, we don't often think of the test stand development environment, the sequence editor. We don't think of that as a user interface, but it is a user interface to test stand. It's the developer's user interface, but you would never deploy this, or you shouldn't. It's not recommended to deploy this to your end systems. Number one, it's too complicated for the average, end user. And number two, it really exposes a lot of functionality that you probably don't want people doing out on your production floor. So typically you're going to deploy something like what's shown on the bottom right part of the screen, a test stand operator interface, either one that ships with test stand or one of your own making that you customized. Then those interfaces tend to be simpler and they offer much less development type capability than does the sequence editor. Then there's your test code. When you think about that, that includes all these things here, your sequence files that you've actually created in test stand, all your code modules, any configuration files that you may use in your application, and any exported limits files. All these things need to get deployed to your end system, right? So you got to get this all out there. And this is another one where people may drop the ball per se, because they only think of the top two items, your sequence and your code modules. And, they say, oh, that's the important stuff. That's what I wrote. That's what I need to make my tests work. But the bottom two things, the exported limits and any config files, that can get missed sometimes. So you definitely want to make sure you get all the assets that your code needs to be functional. So now we know what to deploy in different types. Let's look at recommendations for deployment. First one is use a single LabVIEW version. That's just there, to make things easier, right? You have multiple versions of LabVIEW, you're going to have multiple runtime engines. And you don't need that kind of headache. So try to stick to one version of LabVIEW. Test your modules with the LabVIEW runtime engines. Sometimes when you change over to run your LabVIEW code under the runtime engine, there can be some things that don't work exactly the same or even at all. So you need to make sure you test your modules under the runtime engine. Use a test stand workspace. Test stand workspace is similar to a LabVIEW project, but it's in test stand, it's test stand's analogous functionality to organize all your development files. So first steps you want to take before you distribute your code, you want to run the sequence analyzer. Sequence analyzer is similar to the VI analyzer. You can think of it as that. It runs a bunch of tests on your sequence to let you know if there's any problems like undefined variables or things like that. So you just want to make sure your sequences are actually ready to deploy and you don't have any errors hanging out there that you need to fix. Again, test your modules with the runtime engines, always important. And place the modules in the sequence directory. That way, all the code will be found by your sequence. Because in TestStan, it uses search paths, and one of the first paths is sequence file directory, is where it looks by default. So if you have all your modules there, they will be found. Different deployment methods. The first one we want to look at is a shared network drive deployment scenario, and this is what that looks like. Basically, under the shared network drive, you have a development side and you have a production side, and those two don't really cross paths. They interact through and via the master repository. So on the left, you've got your development computers where your test engineers are actually creating new sequences and test code. When they get done creating that, they can push that up to the development shared drive. And then from there, it goes through a release process and it goes into a master repository on the network. And then on the other side, you have your production testers, and they pull from the production shared drive, which gets all the data or all the assets from the master repository. So in this way, all your production testers, they have the latest code, but there's no real danger that somebody's going to actually edit code that is being used in your production. Another option is to use source code control. So here's what that looks like. You have your developers on the left creating code modules and sequences. They check in those modules and sequences to a source code control server. And then on the bottom right, your test stations can do a get and pull the sequences and modules from the source code control server. And as everybody hopefully knows, the source code control server provides the ability to do things like version control and rollback if necessary. So again, the main idea is whatever deployment method you use, you want to make sure that you diminish the risk that you will edit code that is in use in your production facility. All right, the next part we're going to talk about is the TestStan deployment utility. And you can run this from in TestStan. It looks like this. And this is kind of like where you create a build spec in LabVIEW. And this helps to automate your deployments. So you configure your deployment. In this slide, you're looking at the system source tab. So you specify what all to deploy, and then it pulls it in and automates the deployment process. If you need to deploy the framework, you could do that from the same utility. As you see at the bottom of the screen, there's two check boxes in here that you can check to deploy your TestStan components, your framework components. Different deployment types that you might see or use. The first one is a deployable image. That's basically just a file copy when you think about it. You're copying a hierarchy of folders and files and code to your test system. The next one is an installer. That kind of automates it, right? Because you create an installer that the end user can just run. That's probably going to be a little bit better for an end user versus trying to do a deployable image. But the installer, just like anything else, they just run setup and it does the install for them. Or you could do a package-based distribution. You can create a package in TestStan, and then you can install that using either NI Package Manager or System Link as well, can handle packages. Now, this is key that you test your deployment, and hopefully you do this regularly throughout your development process. So this is just showing the steps you would go through. You identify the components you need to deploy. Then you're going to select your deployment mechanism. Then you're going to get all your code and things ready to deploy. Do any customizations of the components that you're going to deploy, such as your user interface, things like that. Then you can create your deployment. You're either going to do a full deployment. If it's the first time you're deploying, you're going to need to do a full deployment. After that, if you're just updating, you could do a patch deployment. Then you actually transfer the files or do the deployment, execute the deployment, and then you validate it to make sure that everything works once you did the deploy. So you keep going through this. It's an iterative process. You should be doing it throughout your development of your project, because you don't want to get to the very end, where it's 5 o'clock on Friday evening and your tester needs to be up and running at 4 a.m. Monday morning, and you do the deployment for the very first time and you find out you have some problems that you need to work on. Then you end up having to work the weekend or something like that. So test this deployment throughout your development. If you're going to update an existing deployment, that's called a patch deployment. And you can see here at the bottom, there is a radio button where you can select to create a patch deployment. And it's just going to update any changed parts of the code. So you don't need to reinstall or redeploy things that did not change. All right, at this point is where Jomar takes over.
Before we continue, I guess I just want to address just a couple comments. So Steve and Bruce have kind of said a couple things about, like, if you have multiple LabVIEW versions, that means multiple DAC-MX versions or multiple drivers, and usually only the latest version of a driver is allowed. So that's another reason to not have multiple LabVIEW versions. Let's see. Do you deployment test to a machine that has nothing installed to make sure you aren't missing anything? I can say that that's something that we try to do where I am, mainly because we've gotten bitten by that multiple times. Did you have any other comments on that, Steve? No.
That's usually how you learn. You get burned once, but it's good practice to test on a clean machine.
For an incremental deployment, it doesn't apply. Yeah. So I should say that, like, at least at Abbott, we doing patches is much more difficult because we have to do all of the same documents anyway. So a lot of times we kind of treat things as if it were new, at least on the installation side. Okay, so if I'm going to continue, if there aren't any other questions, Mark, you can fill up the slide, I think. So I'm going to talk a little bit about NI Batch Installer Builder, which is something that a little tool that I like. So any NI created installer, you can kind of combine them into one big installer. And so, and you can make one installer and you can put that on your test system, or you can make all of your developers start from the same batch installer files. So at Abbott, and actually at most other places, you standardize on one version of LabVIEW and test stand. Click a few more times, Mark. And then I have a custom test stand UI that I've made, and the installer always puts that in because that way everyone develops to the same UI. For obvious reasons, we also include DAC-MX and we include Visa. If you have LabVIEW driver files, I've made installers for that too. So it's just an executable that puts, let's just say, your Tektronix VIs into instalib. When I do that, all of your developers kind of start from the same spot. All of your test systems start from the same spot. And it's, at least in the procedures that I write, it's like a very easy step to say, get this one startup set of files and install everything. Or on a deployment, you might say, don't install DAC-MX because that test system happens to not have DAC-MX hardware in it. So deployment at Compass is logic, which is where Mark and I used to work. So for most of the systems, we just installed Tortoise SVN on the test computers. And then from there, we would just get the library files and, so like we have a reuse library. So we would get the reuse library, and then test system 1, we would just go to that, navigate to that folder in Tortoise, and then get all of those files. And then from there, if we need to make changes, the developers will check in new code. And then when on the deployment computer, which is also on the regular network, you can just repeat the get process to get something new on your deployment PC. You can click one more time, Mark. Okay. Deployment at Abbott is a little bit different. So we try to have.
See, that's almost ready.
Okay. Sorry for that pause. So we have like one project, test system.lvproj, and we add everything to that project. Any LabVIEW VIs, sequence files, any additional files, pictures that get that are used in prompts, DLLs, that thing. So we create, we use from that LabVIEW project, we create one zip file, we check that into Perforce. This is probably very non-standard, but what I'm in medical again, so all of our documents point to one file in Perforce with one changeless number, and I don't have to bother with thinking about, VI1, we found a bug in that, and then that changed. So of course that changeless number changes, and so on. Like we're trying to encapsulate everything so that we can easily say on this revision, this is exactly what we had. And like we have a reuse library, but of course we occasionally find bugs in the library, and then we can update it. But if the software, if the deployed system was validated with that library in it, and then we can still stick to that. We're very conscious of what versions of everything were done when we do a software validation and verification. Like that's a huge deal at work. So obviously this is kind of a manual process right now, but like I can imagine continuous integration kind of working into that. You check in a change, and then you can kind of run all of your checks and create new zip files from that change. That's a someday thing. Let's see. Moving on. So like what I hate about deployment is when I get the unable to load VI in test stand. And that's just, I think, and if you search for this kind of error, you will find many frustrated posts on the forums about it. And so one of the first, so I'm just going to kind of talk about this error and just like things that I've found that helps. So the first thing would be search directories. So in test stand, you have search directories where test stand will be able to find, let's just say, the model, any of your libraries. That's usually one thing that's missing when you do especially a new computer setup. You might have to add search directories to that test stand installation. I've actually found that for a lot of sequences, I have to run it. So I did my install on a fresh computer. I actually have to run the sequence in development, and then I can switch it to RTE. And like my licensing allows that, so it's usually fine. But I don't understand why this helps. And I've asked NI support before, and they didn't understand either. LabVIEW, there's an option under properties for a separate compiled code. If that's unchecked, you will probably have fewer problems, but I find it's pretty common that that's checked though. So it's, I don't know. PPLs I've definitely had good success with too in deployment. We don't always do that just because we just like having more flexibility without PPLs. But if you do a test and deployment, it should handle all of your dependencies and all of the random things that will branch out from like your top level VI. It should find all of them if you do the deployment method that Mark was talking about earlier. So some of these things may or may not be best, but those are the kinds of things that we do. And I thought that some of those tips might be helpful here.
Awesome. Well, that's all we had for this presentation. So if there's any questions, we'd be happy to take those as well, try to answer those. Now, I can't see the chat right now, Jomar, so.
Yeah, there's nothing in the chat. So.
Awesome. That either means our mics were broken or we did good.
Well, thank you for the applause, whoever just did that. So.
Awesome. All right. Thanks a lot. We appreciate the attention. And
I've got one question for you guys. Have you noticed that when you're loading your test stand deployments and or test stand sequences, is there something that improves the loading performance to make it go faster, especially if you're analyzing the test sequences?
Jomar, did you want to handle?
I guess analyzing the test sequences that's going to be slow, kind of no matter what. And I've tried to ask NI people about this too. And it's much slower in runtime than in development. So one possibility is that if your licensing on your deployment computer can be debug deployment instead of straight deployment where you have to use real-time engines, like if you're able to just run all of your stuff in development, I found that it's much faster. Like that initial where it's preloading the modules where it could take minutes on startup, that's a lot less if you're in deployment, in development for your LabVIEW adapter.
Okay, so you really think it's a development versus deployment or runtime issue as opposed to like the types of you're running or how you've using PPLs versus not or anything like that?
Yeah, I've played around with several things, and I haven't been able to make that significantly faster. Like, if you dynamically load your VIs instead of preload them, essentially that 5-minute time preload gets distributed amongst the first time you run the sequence. So maybe the operator won't notice that as much. But at least where I'm at, operators almost never start up sequences. They're always just there and running. It's only the developers that notice that it takes minutes to load because they're the ones that have to stop and start it all the time.
Right. Once you're actually running, then you just keep it running.
Yeah.
Yeah, that makes sense. Cool. Yeah, I was just curious if you had other ideas, so thanks.
Yeah.
Good question and good answer, Jomar.
All right. Any other questions for Mark and Jomar? Cool. Well, thanks a lot, Mark. Thanks a lot, Jomar, for presenting. This is actually everything we have. So depending on what your expectation was, if we were going to end at 6, we're a little bit late. If we're going to end at 6:30, we're ending early. So Thank you everybody for coming. Darren, once again, thank you very much for presenting. We should be announcing the Q2 meeting here relatively soon so that you guys can plan ahead for that. So keep a lookout for the newsletter. All right. Thank you all very much once again, and have a good night.
Thanks, Will.
Thank you.